everybody. Welcome to the seventh part of the wxWidgets webinar. My name is Pierre Di Passero, and I'm part of the R&D team of Variscite. Today, we will go through the wxWidgets framework, a second part of the webinar that is hosted the previous time about the setup of the framework. But let's go through the agenda. We will have a Variscite introduction. We will go through the general introduction about Variscite. We will summarize what is wxWidgets. We will go through the graphical analysis of the dashboard application, and then we will do a step-by-step demonstration of all the custom graphical objects that we are going to design. And finally, we will check the final graphical result. And then we will have some time for the questions and answers. First of all, let's summarize about Variscite. Variscite is on the market since 19 years ago, and we have an extensive customer baseline and pipeline. We are a stable supplier using internal production facilities and ensuring complete control of our manufacturing process. We directly support the customer through our R&D team, 24-hour days, 7 days per week. I mean, we are spread worldwide. We have teams in US, Canada, Europe, Israel. So we can cover mainly the worldwide, all the requests from the customer. We are the only SOM vendor that is an NXP Platinum partner. And we provide the maximum diversified i.MX portfolio from NXP. So all the SOCs available from NXP, we can provide in terms of SOMs. We have a very high quality standards, meeting regulatory requirements and medical standards like ISO. And we have an ecosystem of partners to provide a complete end-to-end solutions to our customer. The goal of our site is helping the customer to have a fast time to market, reduce the R&D costs. We do provide 2 pin-to-pin compatible families that we will see in the next slide that will enable the customer to quickly migrate between one solution to another in terms of powerful and features. We are 100% AL all the time. We are all our SOM are production ready for other, and we also do provide the software, so you can use our software as it is and eventually customize. We have hundreds of customers that test and use our SOMs, so we are proven high reliability and low risk. We do provide free support for customers through the customer portal. We have open source code through the GitHub and wide documentation through Variscite, plus the files for the hardware. We have in-house production for stable availability and lead times, and we have a robust longevity also granted by NXP through its longevity program. So let's talk about our pin-to-pin families. Mainly, we do provide 2 pin-to-pin families: the VarSOM pin-to-pin family that can range from the low i.MX6UL through the 6, the i.MX8 Nano, Mini, 8X, 8 Code Max, and 8M Plus, the last one that NXP provided. Beside this family, the VarSOM family, there is also the Dart family that include the 8M Mini, the 8M Quad, and the 8M Plus. All these SOMs are pin-to-pin compatible, but keep in mind that all system on chip from NXP can be configured to have a dedicated pin muxing. So we choose dedicated pin options to make them compatible. The customer is always free to customize his configurations. Okay, now let's introduce the webinar. In the previous workshop, we went through the framework and we went through the configuration of the graphical environment to set up the build. Now we will create a card dashboard application with a dedicated look and feel that is quite different from the one that we've seen the previous time. We will still use the wxWidgets framework, but we will create all required special components that are not available by default in the framework, so we will create by our own. We will use all the facilities provided by code blocks and the GUI editor, and we will build the front end and design the application. This is what we expect as final result. So we will have a dashboard with a status bar and some icons, the status of the kilometer traveled, the instant speed, and so on. But let's start understanding what is wxWidgets. So first of all, keep in mind that last time we have seen that with wxWidgets, we have been able to configure the framework through code blocks and its plugins. And we have seen that we have a GUI editor that will allow us to create our own graphical design. We did in the previous workshop simple controls, standard controls like button, label, slider, and what else. But these were looking, let's say, quite standard. Just to summarize, we went through the context device that is a specific object in wxWidgets that allow to create overlap, shades, dedicated shapes of figures, draw lines, and whatever. Let's start to understand what we need now to create the dashboard. So first of all, let's analyze the graphical design. First of all, we need a special background. We need a custom background that is the one that you see in this picture. We will use vertical bar indicators for the oil and the fuel. We will have a status bar on the bottom indicating the date and the time. We will have a cruising indicator with the speed, the total kilometer, and the special run speed indicator that will cover the instant speed. And we will have some dedicated icons that are supposed to provide the status of the car. So, if we go to the previous webinar, we've seen that we were using standard controls that were already available. In this case, we don't have control like this. These are much more complex. So in some way, we need to create a dedicated control because they are not available out of the box. How to create them? Basically, we have three different ways. The first is create a new control combining the existing standard controls. This is sometimes possible. In our case, it's a bit complicated because we don't have something is to be modified in order to obtain what we really want. So this approach is not useful in our purpose. An alternative approach may be create a completely new control relying on the underlying native toolkit that we use for wxWidgets. So for Linux, this is GTK+. For macOS, this is Carbon. And for Windows, this is GDI. But the point is that these are platform dependent. And honestly, we don't want to be platform dependent. We want to have a kind of portable solution. So the best approach is to create a completely new control using wxWidgets classes. This method has the advantage of writing a single implementation that will work everywhere. And the implementation it's quite easy. So let's go through this approach. First of all, we need to remind that all generic widgets are typically derived from wxWidgets control, wxWindows, or wxPanel. Usually, we prefer deriving from wxWindows or wxPanel. because it's more simple. In any case, we need to remind that we need to create a dedicated paint event function using device context to refresh the area that we want to update. We also leave in this page in the bottom the reference official documentation for this approach. Let's see some best practice in order to approach this development. First of all, we should never use the device context outside a paint event. So we should limit all the drawing within the paint event handler, so the dedicated function that we'll have to write for this object. Second point, never assume that your painting will be always there on the screen. What I mean, a pop-up may arise, something may cover your last update, and you should always keep in mind this, because you are supposed to always manage the paint event, in order to make sure that the part that you're rendering is always updated. Even in case something came up and then disappear, you will be called through the paint event, and you are supposed to rewrite or re-render your portion of screen. The third point is always keep separated the data and the state. What I mean, the rendering routine must read values and render the screen accordingly. But the way you update the values must be something independent. Basically, what I'm saying is that there is a kind of state machine that take care of the graphics, and the backend that is taking care of the numbers. And they are separated. Once something happens and the backend update some variable that need to be updated on the screen, the backend is supposed to somehow force a repaint, invoking a refresh that will, by side effect, this refresh will create a paint event. Okay, now let's go step by step and summarize what we need to do to obtain what we need. First of all, we need to create the project. We will select the wxWidgets project. We will follow the wizard selecting the latest 3.1 available wxWidgets, and we will select the wxSmith as preferred GUI and the frame-based application type. This is basically what we have done the previous time. Let's now start talking about the application. The application will need some graphical assets. I'm talking about the list of images that we will use within the application. So if you remember the previous slides where I was showing the final result, in the middle we have the tachymeter, we have a background, we have a series of icons that can be active or not. But these are part of the application. Usually, it's a good practice, store these images in an absolute path. In Linux, usually this happens in a folder named the user share name of the application images. In this case, we brought user share dashboard images. But feel free to use your own approach. This is useful because even when debugging, you will find advantages to have an absolute path when introducing the images. So let's start from the background now. When we reach the wxFrame resource panel, where we are designing the application, the same that we did the last time, we can select the screen form and, first of all, uncheck the default size and force the size of our LVDX, for example, 800 by 480. And then we create a dedicated event handler that will force the rendering of our application, of our background. How can we do this? First of all, the step 1 and 2 are shown in the slide. For the 3, we need to we need to create a new event handler, and then select from the list the add new event add new handler option. This will create automatically a structure in the C code that will allow us to introduce our own on-paint handler. And in the on-paint handler, we will call the device context with the method draw bitmap. To the draw bitmap, we will pass the image that we want to render. In this case, we have the screen background PNG that is one of our graphical assets. So we are creating a dedicated on-paint event that will render this background image that in our implementation is one of the public member of the class. If we compile and run, the graphical aspect will be this one. So we are loading default our background. This is the first step. Let's move on now, and let's start creating. Here we have left the space for the date and the time, so we can start with the date and the time. We can introduce two wx static text label. We will initialize the label with a default value, the one in the label item. We will assign a variable name that we can use in the code later. We can change the background color, the font color, and basically this will be rendered to our display. Before going on, let's do one last step. So let's force dedicated alignment in terms of left, right, center, whatever you prefer, for the string that will be shown. And as last thing to do before starting, let's create a timer. This timer will be used by, let's say, what we call the simulator, because we'll create the system tick that we'll use to update our application. So once we have created also the timer, we selected the timer, and we select also the update interval. When we click on the icon with the two graphs, we can select the handler to be added, and then we create a dedicated handler for the timer. So whenever the timer will expire, this handler will be called. In this part of the code, you will see that whenever it expires, we call the update by invoking the date time function. We get the date and the time, we create the string according to the current date and time, and we do update the display. The final result here will be this one. So we have the background, we have the date, and we have the time. Now let's start with the things a bit more complicated. I mean, till now we use the standard component, but we said that we need the custom component, okay? So let's start with the vertical bars. Whenever we want to create a custom component that is not present in the wxWidgets framework, we can start from the menu, select a new class, and then in the create new class form, we enter the name of the class, in this case, my vertical bar. We say in the inheritance which class we are going to inherit. We are selecting here the WX panel, and we need to always select, at least provide the include file wxWidgets.c. Then we click on the create button. Once we do this, we can see that the code, this code is automatically created. Part of this code is automatically created. The constructor parameter are invoked based on the inheriting the father class WX panel, and the report part of the same variable used for the WX panel constructor plus additional things that we want to use. So we have the constructor, the destructor. We add some specific set and get values function because we want to update this object. And also we need the onPaint function because we want to update the rendering at the screen. As you can see in the set value function, once we need to refresh the value because it is actually changed, we do invoke the refresh for this specific object. The refresh will originate the event, the paint event. The paint event will call the onPaint function. This is the header file. Let's see what happened for the C++ part. So we will have the call to the WX panel default constructor. We will have the onPaint function that we will populate with the code that we need. And we can finally paint according our needs this vertical bar. Once we do this, we still have to introduce our new control in the graphical design. How we can do this? Basically, in the list of possible controls that we can add, one of these is this strange keyhole with the question mark. This refers to generical custom components. When you select this component, you can select which is the include file to be used, and this is the one that we created in the last step. We enter the class var, the class name. We introduce a variable name to actually point at this specific object. And the only strange thing that we need to do, every custom object has a creating code line. This creating code line, by default, is generated for WX control. If you remind, I told that the custom control may be inherited by starting from class like WX panel, WX Windows, and WX control. The WX control is a bit more complex as class and require an additional parameter that is the WX default validator. That is not needed for WX panel and WX Windows. Since we are using here for the vertical bar the WX panel, we need to remove this additional control from the line. That's it. Now we can save and run, and this is the final result. Okay. For your information, you can see that there is a kind of decoration around the bar. This is because we selected the WX panel. If you select the WX widgets, the WX Windows, this decoration is not present. So this is one of the main differences between the WX panel and the WX Windows classes. Okay, so moving toward the right, now we need to add the central tachymeter. The process is more or less the same. We create a new class, inheriting the WX Windows class, so there will be no decoration around it. We need to fill in its constructor parameter according to the wxWindows documentation. We can define the bitmap that will be used as the tachymeter background. We define the set image for this background, and we define the onPaint function. So in the constructor class, we will have basically also the onPaint function that we will draw the image, and you can see here that the device context invoke also the draw elliptical arc. This is the arc that will be used to render the current speed with the green portion of the arc that will render the current speed. Okay, now we need to do something similar in the graphical design as we did for the vertical bar. So we go to the graphical designer, we add the new object, always starting from the from the keyhole with the question mark. We include the file, we set the include file, we set the class name, we provide a variable name, and as previously done, we need to click on the creating code line in order to remove in the text box wx default validator that is only needed for the wx control classes. Okay, once done, we also do need add some string. So, for example, we need to have the kilometers and the instant speed and the related units. And these are standard controls, so we simply add the required wx static text string. For them, we set the font, the size, the background, and keep in mind that sometimes, like in this case, we do want to remove the outer size, because otherwise the size of the screen of the rendered text will depend on the amount of text that needs to be written. So let's remove the outer size, and the font size will never change, even if we are rendering 5 kilometers like 100 kilometers. The font size will not change. Okay. Now let's go to the main C++ code and keep in mind to add the bitmap for the tachymeter background. Now we can compile and run, and this is the expected result. So now we have the date, the time, the graphical bar, the vertical bar, and the tachymeter with the green elliptical arc that actually is a circular arc, but we use for render the speed. Okay, the last step that we are still missing is the icons and the lights. So basically, we need to create something similar to add the icons on the left of on the right of the tachymeter to get the list of icons that we want to render, and the control to change the color in case of notification from in a real machine from the CAN bus, in our case from our simulator. We will skip this because for a matter of time we prefer jumping to the next steps, because basically what we want to see is that we will have some dedicated icons that will load in the code, and will change accordingly to the status. Okay, now we need to animate the GUI. Everything is set up. We need a kind of simulator. Once again, in a real case, you would have the CAN bus that is communicating. In this case, we are just emulating some events with the increment of the speed, the change of the speed labels, some additional stuff about the status icon. We are just simulating some icons that are blinking, not blinking, but are changing their state, and the level bars that are changing their state according to time. Okay, at this point, we are supposed to reach the final result that is something like this. All this code will be available in our GitHub, so don't worry, you can find everything already tested on GitHub. Okay, and now question time. We have a question about the integration between wxWidgets and GStreamer. By default, wxWidgets already integrate GStreamer, and one of the example is a video player based on GStreamer. Since it's based on GStreamer, automatically it inherits the video rendering acceleration if available. So if you're using a SOM that integrated DPU, the rendering will go through the DPU. And we have tested this directly with the wxWidgets community. Okay. We have another question about, can we access a parameter command line from wxWidgets application? Yes. Basically, in one of the methods that are available in the code is the onInit, that is called when the application starts. And you can check some specific parameters that are more or less the same that are available in the standard C. I'm talking about the argc and the argv parameters. They are members of the wxApp class, and you can use basically to understand if there are parameters and what kind of parameter are available. Okay. We have a question about how much is wxWidgets used. Well, let's say that there are several applications using wxWidgets, but you can directly check on wxWidgets.org website. In the About tab, they have screenshots of applications that are using currently wxWidgets. Okay, we have a question about localizations. If wxWidget can be used to localize the application. wxWidget provides a method to support multi-language application. The general idea is that to write all the program in a language that, let's say, it's English, but you need to encapsulate all the string in a kind of macro that will automatically invoke translation. Then there are dedicated tools to generate the languages. So for each string that you generated in English using this macro, you will be able to associate a dedicated translation in your language, in your target language. Okay, let's go on then. Let me remind some useful links. The wxWidgets homepage, where you will see the documentation about the framework itself, the roadmap. They recently, a few days ago, they released the version 3.16. There is a lot of documentation for each version of this framework. There is a dedicated section for the list of supported platform and possible language binding, like Python or whatever. And there is a dedicated page for the license because I remember that it's fully free. And you can find dedicated documentation 3.1 version. Let me remind you that wxWidgets depends on GTK for Linux, and specifically in terms of the graphical backend, it depends on Wayland. Alternatively, you can use wxWidgets over X11. The only mixing support is for the frame buffer, because GTK does not support frame buffer direct access. Here you can find also the link to our wxWidgets example, where you can find within tonight you will find also this application for the dashboard, and also the previous example from the previous webinar. And as usual, you can contact us through our website. This is there is also the mail for our sales@variscite.com. We are reachable through the Variscite portal for the customer, where you can ask private questions, where you can keep your privacy in terms of project documentation, whatever. You can also find our wiki with all the documentation for all the DSPs, and our GitHub account, where you can find all the code for free. Thanks for joining, and hope to see you in the next webinar. Bye-bye.